Bismillahirrahmanirrahim. Assalamu alaikum pa khair ragle. It's me Atif Waqas, and today on demand of many of my students I am going to start lecture series on entry test preparation. Today is our first lecture of that series, and I'll begin with second year physics, and I'll focus on the important concepts and important formulas. That is because here we are not going to derive lengthy derivations, and we are only interested in all those important points that can help us in entry test exams. You would understand solving the problems more smartly, more quickly, and that is because many of the students have the only problem, and that is the shortage of time. In entry tests, you need to work smartly, you need to save your time, and for that you need to have some techniques with you. Here in this lecture series, I will try my best to make you solve the problems smartly, quickly, efficiently, and one thing that you need to do is to practice. Anything you learn here, you just practice it, and you will be able to solve the problems very quickly, very smartly. So here is our first topic, and that is electric charge, and then we will discuss Coulomb's law and then electric field. But what is charge? Basically, we know that anything we can see, we can observe by any means is matter, and matter consists of charged particle. You know that matter is made up of atoms, and atom has electrons, protons and neutrons. Electrons and protons are electrically charged. So matter is charged. But why we cannot feel the charge of materials surrounding us? That is because the number of protons and the number of electrons inside a material, inside a neutral material, inside a stable atom is same. So there is no difference of electrons and protons inside the material. So that is why we cannot feel the charge on them. So in electrostatics, we are only interested in the excess charge. What is excess charge? Excess charge can be calculated by this formula, Q equals Ne. Here N is the number of protons minus number of electrons. It would be an integer. It may be positive if protons are more than electrons. It may be negative if electrons are more than protons. And what is this E? This E is elementary charge. It is the charge on elementary particle electron, but with some negative sign here because electron is negatively charged. And for proton, it is 1.6 × 10⁻⁹ Coulomb. So this is elementary charge. Any material object can have charge as multiple of this E. It may be a negative multiple in case of excess of electrons. It may be positive multiple of E in case of excess of protons. So let's suppose I am having a sphere, and it is conducting sphere, and I sprinkle 10 raised to the power 12 electrons on this. So it gets charged. Initially it was neutral. It was having same number of protons and electrons. So N was 0 initially. And if N is 0, we say Q is 0. Though it has a lot of electrons and protons inside, but it is neutral. That is because excess charge is 0. N is 0. Charge is never 0. N is the difference of electrons and protons. So if I sprinkle electron on this material, we get this much N. This is then the difference, because initially the difference was 0. And if I add some electrons, 10 raised to the power 12, how much is the charge in coulombs? So N is 10 raised to the power 12, Q is 10 raised to the power 12 multiplied with 1.6 × 10⁻⁹ coulombs, and this way I get 1.6 into 10 raised to the power 12 minus 19, we get minus 7. So this is the charge on Coulomb. But here we would be having negative sign. Why negative sign? Because I have added electron to the material. So electrons are now in excess. And that is why I must put negative sign here. So the charge is minus 1.6 into 10 raised to the power minus 7 coulombs. And if you take electron from that material, you take 10 raised to the power 12 electron from that material, in that case then you would be having more number of protons in that material. And then you will be having positive sign here. So accordingly then you practice this. Then unit of charge is Coulomb, you know it, and dimensions of charge Q equals IT. This expression here is the relationship between the derived quantity charge and the base quantities current and time. So we will discuss this in our next chapter when we will be dealing with currents, moving charges. So just remember this expression, we will discuss it in our next chapter. And here is the dimensional formula for charge. So here are the dimensions. Sometimes it is written this way, ampere times T. Charge is conserved, you know that. So by conserved we can solve this problem. That is because when I give some charge to a material, it gets charged, and when I take some charge from a material, it gets charged. So in either way we can charge a material by either giving it electrons or taking electrons from it. Sometimes we can charge things by rubbing. When you rub two materials, charge is transferred from one material to the other, and it is the electrons which transfer. In case of insulators, the charge remains for longer time, and in case of conductors, whenever they get contact with some material, charge is transferred from the conductor. So here is the formula, and this way you can know the number of electrons in the material. If you are asked that what is the number of electrons given to a material if it gets charged by amount of minus 3.2 into 10 raised to the power minus 19. So how many electrons you gave to that material to which you charged this much? So if Q is given this and you are asked to calculate the number of electrons, what you do? You only use this formula, Q equals Ne. This N will now give you the number of electrons. That is because here we are having negative sign. So, but not all electrons, those electrons which are either given to it or taken from it, but in this case we have given it some electrons, so this N would be that excess. And this way N equals Q divided by E. And if you divide this charge minus 3.2 into 10 raised to the power minus 19 Coulomb by what? By E, elementary charge 1.6 into 10 raised to the power minus 19 Coulomb. What you get? You get 2. So the number of electrons is 2. You have given that material 2 electrons. And then similar questions may be asked in your examination. Remember, among protons, neutrons and electron is elementary particle. Protons and neutrons are not elementary. They are subatomic particles, but they are made up of other elementary particles called quark, and we will discuss these things in our modern physics, in our particle physics course. Then we move to the interaction of charges. So whenever there is a charge, there is a field. Charge is coupling factor for one of the natural forces that is called electrostatics. Electrostatic interactions are the interactions between two materials because of their charge, because of their excess charge. So if you are having two bodies and both of them are either positively charged or negatively charged or differently charged, one is positive, other is negative, they interact with each other. What is the magnitude of that force? That is given by Coulomb. And Coulomb's law states that the magnitude of the force between two charged particles depend upon the product of charges. It is directly related to the product of charges, and it is inversely related to the square of distance between the charges. And we can write this expression. There are three things upon which this force depends: the magnitude of charges, and it depends upon the product of charge. It makes no difference maybe if one is 1 Coulomb charge and other is 1000 Coulomb charge. They exert same amount of force on each other. Remember, they exert same force on each other. Even if one is an electron and the other is a heavy nucleus of uranium with 92 protons, they exert same force on each other. The force between them depends upon the product of the charges. So it makes no difference if one is electron, the other is nucleus. If one is 1 Coulomb, the other is 1000 Coulomb. They exert same force on each other. And the other thing about them is that this force obeys inverse square law. If you double the distance, the force reduces by 4 times the square. So if you are asked a question that charge is doubled on two charged bodies and the separation between them is also doubled, what is the effect on the Coulombic force between them? What is the effect of electrostatic force? So you can check it this way: F equals K, because he has not changed the medium. You discuss it. It is in vacuum, so we use K. And Q1 is given is 2Q this time. We have doubled the charges, so you will be having 2Q and 2Q naught, and you divide this by R square. It becomes 2R square. So you have 4 here because of these two, Q naught, and 1 4 from here. So overall there is no effect if you double the charges and if you double the radius, if you double the separation between the charges. So the force remains same. So you may ask the questions like this. Sometimes they say that magnitude of charge is doubled and magnitude of separation between them is halved. Then you just put R by 2 here and 2 and 2 here. In that case, you would be having 4 in the denominator here, and that goes there and multiplied it here. So in this way, if radius is halved, then the force would increase 16 times. So you can solve all those problems by simply keeping in mind that the force depends upon is directly related, is directly proportional to the product of charges and to inversely related to the square of the separation between them. And K here is Coulomb's constant. Its value is 9 × 10⁻⁹. It is 1 divided by 4 pi epsilon naught. Epsilon naught is permittivity of free space. Its units are Coulomb square per Newton meter square. You need to know the units of this Coulomb's constant and that of this permittivity, and that is because sometimes they ask these units, so you need to know it. I should write it here. It is because here are the units of epsilon naught that are reciprocal of these units, Coulomb square per Newton meter square. And then if you insert some dielectric material between the charges, then the force change. The force change by that much amount. The force decreases when you insert some dielectric between the charges. And here is the relative permittivity of that dielectric, K divided by relative permittivity of that dielectric, and you get this way. So whenever a dielectric is inserted between two charges, the force, the interaction between those two charges, the electrostatic force between them decreases. Why? That is because it is in inverse relation to that relative permittivity. A field is developed in opposite direction between two charges when there is some dielectric that gets polarized. But you need to remember that when medium is inserted between two charges, the force decreases. That is because this simple expression tells us. And then if you want to express Newton's law in vector form, you can express it this way. R unit vector or K Q naught divided by R cube R vector. Why R cube? That is because you can substitute R unit vector by vector divided by its magnitude. So the magnitude gets multiplied to this denominator and you are left with this vector. So both of these representations are correct. You can express Coulomb's law in either vectorially. And then we would move to electric fields, but let me erase this stuff from here. Electric field intensity Electric field intensity. Electric field intensity is the force on test charge which is placed inside the field of some source charge Q. Here I place some test charge and the force this source exerts on this test charge is when divided by the test charge, you get electric field intensity. And if I substitute the values of force from Coulomb's law, I get Q naught divided by R square. This Q naught is in denominator, they get cancelled, and we are left with KQ divided by R square. So once again, if you want to express this in vector form, you can have this expression or you can have this expression. And for any other medium other than vacuum, you would be having A medium equals K divided by relative permittivity of that medium, and we call it dielectric constant, and Q divided by R square. So this is the relative permittivity of that medium, and from here you can see if the charge, source charge is placed inside some other medium, its field gets weaker. And once again, because the medium around that charged particles gets polarized and some opposite fields are developed. So this here depends only on source charge, separation from that source charge, this position R. If you check it here, it would be having some different value. If you check it here, it would be having some different value. It does not depend upon the magnitude of test charge. It makes no difference whether you test it by bringing some charge with the less magnitude or higher magnitude, it only depends upon the magnitude of source charge. So and separation from the distance from that charge, and it depends upon the medium. If it is free space, it is more in vacuum than in any medium. And once again, that is because this epsilon r is always greater than 1, and it is in denominator. So the field gets weaker when the charged particle is inside some dielectric material. So you need to remember these things. It does not depend upon the test charge, it only depends upon the source charge. It only depends upon the position of that point with respect to that source charge, and it depends upon the medium. And then its graph. So if I draw graph of electric field versus R, so it is different for different cases. I am assuming some point charge. For point charge, the size is almost 0, so it is here somewhere, and initially it very close to that point the field is E, and as I move farther from that, this is R, so the field gets weaker and weaker, and it is inverse square, so the graph is like this. So E is proportional to 1 by R square. And if we draw the graph between E and R for some charged conducting sphere. Now for conducting sphere, inside that conductor the field is 0. So electric field is 0 inside. This is the radius of that conducting sphere. Let's suppose it is like this. And outside that conducting sphere, the field is maximum. So this is some maximum field here, E at surface. And then after that surface, the field once again proportional to 1 by R square. So here it is 0, and then its surface it is maximum. And if it is some charged sphere or some three-dimensional distribution of charges, then for here we are having any charge inside that conducting sphere. Charges, all the charges spread at the surface, so no any excess charge inside that conducting sphere, so the field is 0. But if we assume the situation when there is a charge inside that sphere and the distribution is like this, we are having some excess charge inside, then the field is like this. The graph is like this. This is R, this is E. So inside that sphere, E is proportional to R. It is maximum at the surface, and once again outside that surface the field is once again like this. Let me change it a bit. Like this. So this is E is proportional to 1 by R square. So these are different cases, and when we can draw the graph between E and R. This is for distribution of three-dimensional distribution of charges. This is for conducting shell or conducting sphere, and this one is for point charge. and in all the cases you are having this steep curve. That is because of inverse square law. And if the graph is between E and 1 by r square, then this graph would be straight line. And one other thing about the graph, you should have knowledge. You should have knowledge of two things about any graph. One is slope of the graph, and the other is area under the graph. You may be asked in the exams that what physical quantity is represented by the slope of the graph. So for slope, you just divide the unit of vertical axis on unit of horizontal axis, and you get the units of slope or the dimensions of slope. And for area, you just multiply the dimensions of this vertical axis and the dimensions of this horizontal axis. Here it is length and here it is electric field. Electric field units are Newton per Coulomb or volt per meter. So area of this graph have the units of volt per meter multiplied with meter, it means voltage. So similar questions may be asked. For slope, just divide the units of these two. For area, just multiply the units of these two and you get the result. Thank you very much. Stay blessed. Allah Hafiz.